Curiosity in society is high to know the results of convalescent plasma therapy, actually that claims to kill coronavirus in blood. But let's see whether it serves the purpose or just another fooling around of America. Children, try to recall my one of the previous video lecture in which I left one question unanswered, that why the mixture of ink and water or milk and water was looking homogeneous, but I told at that time that no, it is heterogeneous, and I told you that I will solve this doubt in my another video lecture, and now I am ready with the answer of that question, because today's highlighted topic is nothing but the colloids, which I am promising you since last 2 classes that I will take colloid. So today actually I am taking colloid. Colloid, which sounds also little different from the solution and suspension, actually is an intermediate situation between the 2 types of solution, that is your true solution and suspension. In the middle, colloid is actually found. Colloid is a type of solution in which the solubility is not full nor absent. Means the solubility is partial. The substances to an extent dissolve and the remaining part of the solute doesn't dissolve. In such a kind of situation, what happens that the dissolved substance looks invisible and makes the solution looking like homogeneous, and the undissolved substance makes the solution appearing little translucent or hazy. So colloid creates an illusion of a homogeneous mixture, but by gaining knowledge you will know that no, it is not homogeneous, it is also heterogeneous, and because it can be separated by using the different techniques, which is your centrifugation and all. Because if the solution will be completely homogeneous, then no other method is there except the evaporation, which is in the case of true solution. But here colloid is not separated, can't be separated by evaporation, it is separated mainly by the centrifugation process. So the mixtures like milk, oil, rice water, means when we cook the rice and we strain the water, that rice water is also a very good example of your colloidal solution, etc. are good examples of our day-to-day life when we observe colloidal solution. But here one thing is to mention very clearly that like the true solution, I told that any state of matter can make the true solution. Here also it is applicable. Any state of matter can make a colloidal solution. A fog, which is a mixture of fine dust particles suspended in the air, and the liquid water is held up in the air. So liquid and gaseous mixture is your fog. Gaseous is your air, and the liquid is your condensed water particles. That is a colloidal mixture. Colloidal mixture will always appear translucent in your appearance. Why? Because wherever there is a transparency, it means it is a true solution. True solution will always be a transparent in appearance, whereas a translucent medium will be a colloidal solution, where light is absorbed little much and passes through the medium also little much. It crosses the medium and it is absorbed by the medium also. So in this situation, a colloidal appearance is seen. So let us discuss about the features of colloid, means what are its properties. Like I have told you that the true solution is always a homogeneous mixture. It will be a heterogeneous mixture, but not as heterogeneous looking like suspension. It will look homogeneous, but it is actually a heterogeneous mixture. Then the particle size is neither as big as suspension, which can be clearly seen with the naked eye, nor it is so invisible and tiny that it will be invisible from the naked eye. But individual particle, single particle, you can't see from your naked eye. In the case of colloidal solution, it will look in the bulk. It will make its appearance in the whole mixture in totality, but a single particle individually can't be seen. Why it happens, that will be cleared in your lab class, because the size of the particle is intermediate, which is around the 10 to the power minus 7 meter, which is less than 10 to the power minus 9 meter in the case of true solution. So it is totally invisible, and it is bigger than 10 to the power minus 5 meter in the case of suspension. So it is totally visible from our naked eye. But it is intermediate situation where the particle size is 10 to the power minus 7, which is neither a very clear vision range nor it is an invisible range. Try to observe this picture given in the NCERT book, which says that it is picture of Tyndall effect. What is it actually? It's looking like the picture of a dense forest where the sunlight is falling and making the lower area of the forest illuminated, where the light cannot reach because of the dense leaves which cover up or make the canopy inside the forest looking like umbrella. So what is the Tyndall effect? Yes, this is actually the most you can say the unique property of colloidal solution. Tyndall effect is most unique property of colloidal solution. Yes, because it is the single mixture which shows the best kind of Tyndall effect. Tyndall effect is nothing but what I am telling you. So here I am ready with my all work done for the Tyndall effect, because this was my contemplated topic. I was thinking about it, so I have done my homework also a little much. So what is Tyndall effect? It is nothing but a fashion of light when it crosses through the colloidal solution, a pattern of light, I will say. What happens that when a light rays passes through a true solution, then true solution particles are so small that their size is negligible around, so they do not play any obstacle in the path of light, and the light crosses through the solution very well, and it is not seen inside the solution. What is not seen inside the solution? The path of the light. Means the blue color of copper sulfate solution, which is a true solution, will not show any path of the light when you have projected inside it through your source, which can be your LED torch, etc. But if you have taken a very fine solution like milk of magnesia or clay water, where the particle is very small in size, then what will happen? Or if you have taken a true colloidal solution like milk, like ink and water, etc., then what will happen? That when it will encounter the mixture, when the beam of light is projected and it will go through the colloidal solution, what will happen? The colloidal solution neither will play pure obstacle so that the light cannot pass through it and it will make the solution dark, nor it will allow the light to cross without any obstacle. It will play a small obstacle actually, and then what will happen? The fine particle of the colloid which are in the held up situation will allow the light to bend. So one light will be scattered minimum into 2 rays by colliding through the colloidal particle. When it will encounter a colloidal particle, it will minimum disperse into 1 ray into 2 ray. Naturally, the light will be more illuminated because the source of light is coming in a limited way and it is getting illuminated by colliding the colloidal particle. So this will make what? That it will make the path of the light visible inside the solution. You will see a kind of illumination that light is passing through the solution and it is coming out. This will be seen very nicely in the colloidal solution, and this is called scattering of beam of light, and this is nothing but the Tyndall effect. Tyndall was the scientist who studied about it, and just to honor him, the name of the phenomena also has been given by his name. So well, you will get surprised to know that many environmental phenomena also actually are the good examples of your colloidal mixture, like fog. Just now I told you that it is nothing but a colloidal mixture, like a canopy in the forest which scatters the beam of light through the leaves of the big leaves of the forest, because the leaves have what? You can say that how do the leaf form like a colloidal solution? How can it play like a colloidal solution? So try to understand what happens inside. The leaf is actually a medium which has a chlorophyll inside it. Chlorophyll particles are so tiny that when the sunlight comes over the leaf, it gets obstacle little much by the chlorophyll and it gets dispersed and scatters the beam of light. And leaves are actually a translucent medium because they allow the light to pass through them partially. So leaves of the forest is a good example of to scatter the beam of light, which is the canopy of the forest. Then fog is good example. Then fine suspension like clay water. Then starch water. I am already telling you that the starch water is also a good example. What is starch water in day-to-day life? When we strain the water after cooking rice, then it will be starch water. And starch water is a very good example of colloidal solution. Now try to know other properties of the colloidal solution. What about its stability? I told you that if the mixture doesn't change its appearance with stirring and setting or settling, then it will be a stable mixture. So colloidal is a stable mixture. If you will leave it undisturbed for some time, or after some time if you will stir it also, it will look same. It will not change its appearance. So it is a highly stable mixture. Then how to separate a colloidal mixture? So colloidal mixture cannot be separated by the process of filtration. Filtration will not separate the colloidal particles on the filter paper and allow the filtrate to pass through it, because the colloidal particles are so intermediate in size that they clog the filter paper. Means the size of the colloidal particle is equally around same, which is the pores of the filter paper. So you will see that in the beginning the filtrate is passing through, means water will pass through for some time only. After around 1 minute you will see that the flow of the water is becoming slow, and then it stops, because the colloidal particle go and clog the filter paper and they make the filter paper just useless, because the filter paper pores are becoming clogged by the colloidal particles, and it does not allow the mixture to pass through it, and so the filtration process remains failure in the case of colloidal mixture. So what is the right separation process? I am telling you that it is a centrifugation. When I will start the separation method, which is the bigger part of the chapter, naturally in many type of separation method we will adopt the process that is called your centrifugation. Now come to the last related knowledge about the colloidal solution. Colloidal solution has two components. Every solution has two components. One is your called solute, another is your called solvent, and the mixture of solute and solvent is your solution. But here we talk little more scientifically. The solute in the colloidal mixture is called dispersed phase, and the solvent in the colloidal mixture is called dispersion medium. This you will always keep it in mind, that dispersed phase and dispersion medium together make a colloidal solution. So that's how I taken up the colloidal solution at my level best, and then I am trying to move towards from my next class towards the separation methods one by one.